Hello everyone and welcome to another YouTube video. Today I will be briefly discussing triangles, and hopefully you guys will take a lot of information away within these matter of minutes. If you guys enjoy the video, make sure to like, comment, and even subscribe to my YouTube channel to be updated on more videos that I try to provide to you guys. It really helps me out as a young creator, and I really hope to be able to provide you as much content as possible to give you kind of an upper hand in understanding these areas of mathematics, engineering, and even science. So let's get right into the video. So a definition for a triangle is a three-sided closed polygon with three angles whose sum up to 180 degrees, or pi radians. Triangles are identified by their vertices and the symbol delta. So, for example, we have a triangle ABC, which would be written out on the left side, and on the right side is a simple schematic of the triangle. Aside from the points or the angles being labeled capitals A, B, and C, the sides that would be kind of correlated to those angles would be lowercase a, b, and c, and they would be opposite of where the angle or point would be. Angles could also be considered as the alpha, beta, and gamma symbols. So for right triangles particularly, a right triangle is a triangle in which one of the angles is 90 degrees. Shown here is a schematic of what a right triangle would symbolize, and a giveaway for most right triangles is the square in the bottom right. So a reference angle, which would not be the 90-degree angle, is considered theta. There are x and y variables on those sides. X is always going to be considered adjacent side to the reference angle, and y will always be opposite from the opposite side from the reference angle theta. And lastly, the longest side of the right triangle is the variable r, which is the hypotenuse. It's not only the longest side, but it is also on the opposite side of the 90-degree angle, or the right portion, which makes it a right triangle. So after going through the right triangle breakdown, let's go into some trigonometric functions. So shown here again is the schematic from the previous slide, and here are some of the trigonometric functions where there is sine theta, cosine theta, tangent theta, cosecant theta, secant theta, and cotangent theta. Now, some of this might be mumbo jumbo to you guys, but eventually this will be very easy to understand and utilized if you're trying to eventually determine what theta is, or if what cosine theta, for example, would be equal to. And on the right side of the equations is how we break it down. So let's go one by one. So sine theta is equal to y over r, which is the opposite side over the hypotenuse. So say if you're trying to find what that angle of that triangle is, which is theta, you would divide both sides by sine, and if you knew what the opposite side and the hypotenuse side are, you could easily find what the theta or degree is at the reference angle. And that system and process would kind of carry on throughout these other ones, but the equations would be different. So for cosine, we would do the adjacent side, which is x, and divide that by the hypotenuse. For tangent, we would do the y variable over x, which is opposite over adjacent. And when we go to cosecant, secant, and cotangent, they are kind of like the inverse of sine, cosine, and tangent. So cosecant is the inverse of sine, so it would be r over y, or hypotenuse over opposite. For secant, it is the inverse of cosine, which is r over x. And lastly, the tangent and cotangent are inverses of each other, and cotangent would be x over y. So it may take a little bit to understand and remember all these equations. If you understand what sine, cosine, and tangent are, and you understand what they correlate to, like sine is the inverse of cosecant, it kind of simplifies and breaks down these formulas even easier than what you're viewing right now. So to wrap this video up, let's get right into an example problem. So let's try to find the values of cosine of 45 degrees and tangent of 45 degrees. So going back to a right triangle, let's say our reference angle, which was given to us, is 45 degrees. So, which is an easy scenario. We don't know what the sides are, but we can assign them values to kind of have an understanding of what factor they would have effect on what the values would be. So let's assign x and y to be values of 1, and you can determine what the hypotenuse is by using the formula a squared plus b squared equals c squared. A and b being the adjacent and opposite sides, and the c being the variable for the hypotenuse, which is unknown. So to solve that, you would do the square root of 1 squared plus 1 squared, which would be the square root of 2, which is how we determine what the r value would be. So let's jot out the equations that we were just introduced to with cosine theta and tangent theta. Cosine theta being x over r, or the adjacent value over the hypotenuse, and the tangent theta being equal to the opposite value over the adjacent value. So starting with cosine theta, when we substitute these values in, we get an adjacent value of 1 over the hypotenuse of square root of 2. Now, with the square root of 2 being on the bottom, we are actually able to multiply that to the top portion, and then the bottom portion would eliminate the square root of 2. So that's how we were able to determine what the cosine of 45 degrees would be. And now let's transition over to the tangent of theta, which is much easier, which is just 1 over 1. And 1 over 1 in a fraction is simply put 1. So if you put your answer as C, you would be correct. So that concludes my video on triangles. I hope you guys enjoyed it and had some information and enjoyed the video. And if you did, please make sure to leave a like, even comment in the video, and subscribe to my channel. It would really benefit my new channel and hopefully allow me to pump out more information to you guys. Alright, have a great day everyone. Hopefully you enjoy this, and hope to see you guys in another video soon. Bye.